So this was where we stopped the last lesson. I showed you how to find the site for x in practice 3a. So the rest were your homework. So check through. Part B, finding the value of x is just simply writing the equation. Right, we have got x squared, which is the one of the shorter side, plus 21 square. It has to give us 29 square, the square of the longer side. So whenever you start writing the first equation for the Pythagoras theorem, it has this format: something square plus something square equal to something square. Then after that, you can manipulate. But I also mentioned that you can easily write down x squared will be 29 square minus 21 square as well. Okay, so this is okay. Then after that, of course, you have the same expression, 29 square minus 21 square, and you square root the entire thing. Get the answer? Round off if necessary. In this case, it is exactly 20, so it's fine. Part C. Okay, so mixing in a little of isosceles triangle. So we've got x on both lengths. So we're going to end up with 2x squared equals to 100. X will be square root 50 and you get 7.07. Because you write down the value, then you round off a standard practice. And in part D, we throw in more algebra. This time we're going to test your expansion of 2x minus 1, where you square it, as well as 2x plus 1, and you square it. Now in this case, you're going to end up with a quadratic equation: ax squared plus bx plus c equals to 0. And when that happens, you so far only know of one way to solve quadratic equations. That is, for you to factorize into two parts. You are familiar with the idea of using this box to factorize. Usually, you end up with x plus or minus something, multiplied by x plus or minus something else equals to 0. This is the usual case. And then you will end up with two answers: x equals to something or x equals to something. But in this case, this is the easier question in the sense that we do not need to use this to factorize because there are only two terms and x is already a common factor. So we're going to end up with x times x minus a equals 0. If we were to solve this equation mathematically, if we just focus on this and just solve it, we do get two answers: x equals to 0, x equals to 8. There are two acceptable answers. But this question has a context. The x actually belongs to this triangle. Where does it appear? It appears in all three sides of the triangle. Let us focus on two of them. Okay, this as well as this length. Now think about it. If x is equal to 0, does the triangle make sense? Can there be a triangle with a side, the vertical line, equal to 0? Cannot be lah. That's why we reject. In addition, look at the horizontal line, 2x minus 1. If x is equal to 0, then the horizontal length will be 2 times 0, which is 0, minus 1 is negative 1. How can we have negative length? So all the more, we need to reject x equals to 0. That leaves us with only one answer: x equals to 8. Okay, part E, there are two triangles over here, both of which are right angle triangle. How do you know? Well, one of them has a 90-degree over here. Because this is one straight line, we've got adjacent angles on a straight line adding up to 180 degrees. So the other must also be 90 degrees. Okay, now let us find, I think we can find the smallest. We can try and find this first. Focus on a small triangle, 3, 4, and x. Okay, by extracting out the triangle, kind of like how you dealt with your similar and congruent triangles. By extracting the relevant triangles out, you are not distracted by any other extra information. So here, use your Pythagoras theorem, you find that it is equal to 5. Next triangle, the bigger one, the length of AC is y plus 3. y plus 3. We've got y over here and 3. So then this is actually an easier question compared to part D, okay, where you only have one expansion to do. So I'll repeat myself. Whatever you have learned previously serves as a fundamental. Serves as the fundamentals to whatever we're going to be learning in future. Pythagoras theorem over here will be used for additional questions, more complicated questions in future also. And now, another variation, we've got a trapezium. This happens to be a right angle trapezium. We can form a right angle triangle over here. Okay, now because we know the distance DC to be equal to 10, we can form a right angle triangle such that we can form a right angle triangle plus a rectangle to give us our trapezium. So if you include an additional point E, we call E to be 10 units as well. That must imply that A to E also has a distance of 10 units. And then with your 10, 13, we can find our x, Pythagoras theorem again. Okay, at this point in time, am I going too fast? Anybody? No, huh? Okay, textbook questions due Wednesday. Okay, no lesson tomorrow. Okay, Pythagorean triplets. It is just something that is rather interesting now, okay? It is not a must know. The more Pythagoras theorem questions you do, you will find that there are some pairs. Oh, you don't have this page, huh? Oh, okay, then never mind. Don't need. I said don't need. Basically, Pythagorean triplets just are three numbers, three integers, three positive integers that form the sides of a right angle triangle. Can you all name one of them? One that we've seen so many times. This is the one. 3, 4, and 5. When you have a right angle triangle, if this is 3, this is 4, automatically you should be able to tell me that this is 5. Okay, but during the exam, you must still show me Pythagoras theorem, okay? It's just that you do so many times, you realize some numbers are repeated. The other very common one that we like to set for your test will be 5, 12, and 13. Of course, there are many, many other such integers that can form the sides of a right angle triangle. Okay, but most of the time we're going to actually end up with all these decimals because of the square root that is involved when we are solving for a side of a right angle triangle. Okay, so we'll skip this part. Okay, now I want to talk to you about something like cause and effect. You understand cause and effect? For example, if you eat some food that has gone past its expiry date, most likely you'll get a stomachache, right? So why do you get a stomachache? It is because you ate the food that has gone bad. Get it? Okay. So when somebody has a stomachache, you can narrow it down to one of the reasons, one of which is probably ate something that has gone bad. Okay, so what is the cause? The cause is eating something bad. What is the effect? Stomachache. Now I will refresh your memory on this. Okay, give you some keywords, huh? Corresponding angles, parallel lines. Refresh your memory, huh? Of course, this can be applied for your alternate angles, interior angles as well. Question: what is the relationship between A and B? A and B. Do they look like they are the same? Yeah, because they are the same. What is the reason that they are the same? We can write down A equals to B. What is the reason? Oh, it's over here. Corresponding angles, parallel lines. Corresponding angles, parallel lines. The reason we can say that A is equal to B is because of the fact that I have a pair of parallel lines. It is because I have the parallel lines. That is why I can apply this relationship and find out that A is equal to B. What is the cause? The cause is the pair of parallel lines. What is the effect? The effect is A is equal to B. So if I tell you further that A equals to 120 degrees, then your conclusion will be, hey, Mr. Wong, B also is equal to A, which is also equal to 120 degrees. Why? Because there are parallel lines, corresponding angles, parallel lines. So we covered this in the past already. Okay, now, if I didn't say that they are parallel lines, if I did not tell you that they are parallel lines, can you similarly conclude that A equals to B? Can or cannot? Cannot. There's not enough information. I cannot conclude that they are parallel lines. So this we can put a question mark. I don't know. Depends on whether they're parallel lines, right? But what if I tell you instead that the fact is that A equals to B. I tell you that A equals to 120 degrees. B also equal to 120 degrees. They are the same. Okay. So now what is your conclusion? Let's call this W, X, Y, and Z. Can you conclude anything about these two lines, these two horizontal lines? Instead of me telling you that they are parallel, and therefore the angles are the same. This time I do it the other way around. I tell you that the angles are the same. Can you conclude anything about the straight lines? You should be able to, and that they are parallel, right? Because for A and B to be equal, those two lines had to be equal, had to be parallel in the first place. So you can see this form of reverse argument. We call it a converse. We call it a converse. Converse is kind of like reverse. So we say by the converse of what? What were we using over here? By the converse of corresponding angles, parallel lines. Since A equals to B equals to 120 degrees, we conclude that WX parallel with YZ. By the converse of something. Okay, so this is our key phrase, which is what we initially used going forward. Because they are parallel, that's why A and B are the same. Now we are saying by the converse, converse meaning the reverse of the same idea, we conclude what was originally known. Okay, so what is the cause over here? The cause is there is something that we needed to know. Is always that lines are parallel. Effect will be A equals to B. So if we go this way, we call it corresponding angles, parallel lines. But if we go the other way, if we reverse it, then we call it converse of corresponding angles, parallel lines. Okay? So why am I talking to you about this? What does the Pythagoras theorem state? What is the condition? Condition, otherwise known as cause over here. Condition. What is the condition for A squared plus B squared equal to C squared? And the condition is that it must be a right angle triangle. So remember what we drew in the last lesson? I asked you to draw a right angle triangle. That was the condition. It is only because it is a right angle triangle. That is why we have the relationship a squared plus b squared equals c squared. That is the correct flow for Pythagoras theorem. For a right angle triangle, given a right angle triangle, if the triangle is a right angle triangle, those are the conditions. Then we can state that sum of the squares of the two sides equals to the square of the shorter side. So with this idea, what do you think the next portion is about? What am I going to be teaching you next? With all this idea about converse, 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 going backwards, going backwards. And it's answered over here. Given a triangle, how do you prove that it's a right angle triangle? So if I give you a triangle, how do you prove that it's a right angle triangle? A primary school kid will say, I'm going to measure this angle. If it is 90 degrees, it is a right angle triangle. Okay? What if the diagram is not drawn to scale? In our secondary school, it's not drawn to scale. You cannot measure in your protractor. What if I tell you that this is 3, 4, and 5? Can you conclude that this is a right angle triangle? Can conclude? Yes. Early on, we saw, right? This is an example of a Pythagorean triplet. A squared plus b squared equals c squared. Mental sum. 9 plus 16 is 25. Square root 25, you get 5, right? We are working backwards. We are checking. Hey, 3 square plus 4 square is 25. Okay, 5 square also equal to 25. Ah, okay. Since they are the same, by the converse of Pythagoras theorem, this triangle is 90. It's a right angle triangle. So that's how we use it. Okay, presentation, very important. Okay, so later on we will see. In a triangle, the square of the longer side, if they say if the square of the longer side is equal to the sum of the squares of two shorter sides, then the angle opposite the longer side is a right angle. Okay, so basically they are telling you that if a square plus b square equals to c square, if only you have to check if there is such a relationship, then the angle opposite the longer side is our 90 degree. This is known as the converse of Pythagoras theorem. So you need to know how to spell all these. Okay? So without looking at the subsequent solutions, if you have not written anything else, your notes from here, I just want you to try it out yourself. Maybe you'll make some mistakes. Maybe you wouldn't. It's okay. We'll find out. Let's say this has a value of 3. This has a value of 4, and this has a value of 5. Okay, I want you to show in the space over here. Try it yourself. Are you able to prove to me whether this triangle is a right angle triangle or not? Okay, try it yourself now. I'm interested in the presentation. I want to share a story. When I first started teaching mathematics in Evergreen, I had to do this topic. There was a question similar to this. Prove whether it's a right angle triangle or not. So I was there teaching on the board, and then my boss was at the back observing my lesson because one of my first few lessons. So I went, I wrote this. A square. Hang on. I wrote a square plus b square equals to c square. The moment I wrote this, right, I know I made a mistake already. Alternatively, if you wrote this, 3 square plus 4 square equals to 5 square, not as crucial a mistake, but wrong presentation. If you started off with any of these two, then you are heading in the wrong direction. Okay, check our work. Do you have something like this? A square plus b square equals c square? Or do you have something like this? 3 square plus 4 square equals to 5 square? Of course, another equivalent one will be ac square plus bc square equals to ab square. If you have something like this, you have started off wrongly. And okay, so if that is you, which is I understand majority of you, please put a cross so that you do not repeat the mistake again. And I'll explain why. I understand why you make this mistake. I made a mistake also. take a close look at the Pythagoras theorem again. Where was our Pythagoras theorem? It says that in a right angle triangle ABC, you are given the information. It is a right angle triangle. Only if you are given the information, then you can state that A squared plus B squared equals C squared. Okay? What is the condition? Must be right angle triangle. Only when you can confirm that, then you can write this down. If you didn't confirm that, you cannot write it down. Get the difference? Now in this portion of the notes, we did not know. We did not know whether this particular triangle was a right angle triangle or not. So if you had written A squared plus B squared equals C squared, you are telling me that I already know it's a right angle triangle. But do you really know? No, we don't. So you cannot write that. Next, of course, AC squared plus BC squared equals AB squared. Of course, it is the same. Now, what if you have written 3 squared plus 4 squared equals 5 squared? Then it becomes difficult for me to mark because I know you are thinking of Pythagoras theorem. You are just writing down 3 squared plus 4 squared equals to 5 squared without actually considering the values of 3 squared plus 4 squared yet. You have not considered the value of 5 squared yet. When you wrote down 3 squared plus 4 squared equals to 5 squared, you are actually quoting the Pythagoras theorem. Okay, so mathematically not wrong, but I know that you don't have the correct concept. That is why you wrote this down. So we don't accept this as well. Now, how should we be presenting this? We should be writing. We should be thinking in a logical manner. Remember, condition was square of short. If it is a right angle triangle, then square of short side plus square of short side equals square of long side. To prove then that this is a right angle triangle, I should be finding out, what if I take the short side square plus the long side square? This is my train of thought. If I add the 3 square and the 4 square, I find out the value, and then I check that value. If that value is the same as the square as the longer side, if the values are the same, then it must be a right angle triangle. That is the logic. So the presentation has to look like this. B square plus C square equals to 3 square plus 4 square. Don't write down that it's equal to 5 square yet. You do not know. We are trying to find out this value. 9 plus 16, which is 25. Okay, that's one part done. And now I'm going to check out the value of the square of the longer side. So, no, I wrote wrongly. B square plus A square. Then I'm going to check out the square of the longer side, which is C square. C square equals to 5 square, which is 25. It is the same 25. So I prove it to the marker. Hey, I know that it is the same by writing it this way. Equals to B square plus A square. I am showing you that I'm working backwards and I'm seeing that C square is equal to the sum of the squares of the two sides. And therefore, by the converse of Pythagoras theorem, you have to spell it out. Our triangle, or we can say the angle ACB equals to 90 degrees. Angle ACB equals 90 degrees. This is a right angle triangle, blah, blah, blah. Acceptable, okay? Strictly speaking, you should be talking about the angle, not the type of triangle that it is. Because we are able to identify exactly which angle is 90 degrees. So I just want to use this opportunity to remind you that your weighted assessment, the upcoming one in week 6, is on what did I say? Monday, right? Did I say Monday? I remember there's an error in the hard copy slip that was given to you. Yes, our WA3 is on 2nd August. It's a Monday. The hard copy paper that you receive shows 3rd August. It is brought forward by 1 day because Tuesday no maths lesson. We cannot have tests on Tuesday. It has to be Monday. And the topics will be chapter 5, your quadratic graphs, as well as your chapter 8, Pythagoras theorem. Just these 2 topics. Let's continue with practice number 4. In this diagram, point D, okay, let me use the blank version. In this diagram, D is a point on the side of AB of triangle ABC. So that's our point D. Given the distances shown, show that angle CBA is 90 degrees. CBA. Okay, watch the screen now. Everybody look at the screen. Look at what I'm going to do. Watch, watch, watch. What do you think? I just drew 90 degrees over there. What do you think? Should I do that? Should I do it? I shouldn't. I haven't shown it yet. Right? The fact that I drew this box over here means that I confirm it's 90 degrees, but I haven't confirmed it yet. Okay, so just draw a marking on your diagram as per any other usual angle. It could be 90, maybe it is not. Obviously, we know that it's going to eventually be 90 because the question said show that it's 90, right? But just so that you have the correct approach. At this point in time, we don't know that it is 90 degrees yet. Therefore, we shouldn't be indicating it as a 90 degrees yet. Okay? So now, let's try and figure out whether it actually is 90 degrees or not. We're of course going to do so by using our converse of Pythagoras theorem. So we're going to check the square of the short side. We're going to add that to the square of the middle side. We're going to find out the value first. And then we're going to compare it with the square of the long side. If they are the same, we have to conclude it is going to be a right angle triangle. Angle CBA is 90 degrees because that's the converse of Pythagoras theorem. So let's begin. AB square plus BC square. We are trying to find out what this is. So AB square will be 45 square. Plus, the other one will be 28 square. Find out what this value is first. Do not write equals to 53 square. The moment you write equals to 53 square, wrong. Because we don't know yet. We are trying to find out. So 45 square plus 28 square. 2809. And now we find out what is the length of the longest side. AC square. 53 square. (2809). Now we have shown that the sum of the squares of the shorter side equals to the square of the longer side. Then there must be only one conclusion. That angle CBA is 90 degrees. So from here, you carry on and say that, hey, this is equal to AB square plus BC square. Right? Earlier on, we found out that AB square plus BC square was equal to 2809. The same 2809 must be our AB square plus BC square, which is equal to our AC square. Understand the logic behind the presentation. Because they are the same now, we conclude that by the converse of Pythagoras theorem, angle CBA is 90 degrees. Because the question asks you to show that it is 90 degrees, you don't go and say that it is a right angle triangle. Answer the question. Shown. So that's how we do it. Okay, you try practice 5 now. You try practice 5 by yourself. In case you're wondering, hey, there are 3 sides. Should I be randomly choosing 2 to square them and adding them up? Should I be randomly doing that? Answer is no. You should be adding up the 2 shorter sides. You should be adding up the squares of the 2 of the shorter side. compare with the square of the longer side. Okay, try it now. Presentation, important. Okay, so part A, choose the square, sum of the squares of the two shorter side. AB square plus BC square. Find out what it is. So since AC square equals to AB square plus BC square by the converse of Pythagoras. So I really should find out how to spell Pythagoras. 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 By the converse of Pythagoras theorem. Triangle ABC is a right angled triangle. And then in part B, we notice something different. This time, let's take the sum of the squares of the shorter side. So xy square plus yz square, 130, 140. 36500. And then we have our longer side, xz square, 150 square, 22500, which is not equal to xy square plus yz square. So I was happy to see many of you use this symbol, not equal to. So this time we are going to have a different conclusion. Since xz square is not equal to xy square plus yz square by the converse. Same thing, by the converse of Pythagoras theorem, triangle xyz is not a right angle triangle. Okay, so carry on with practice 6. Mixing in some algebra again, but the idea is still the same. How do I decide that the angle is actually PQ? Why not something else? In the first place, are you puzzled by my first equation? When I state PQ square plus QR square equal to PR square, are you thinking how you know? Maybe it is PR square plus QR square equal to PQ square? All right, how do you know? When the numbers are given to you, it is very obvious. The short side squared plus the middle side squared must be the longest number squared. But in this case, we've got some algebra involved. Then you must think of it logically. If one of the sides is 3x, if it is 3x, then x cannot be 0, right? X cannot be 0, otherwise the length will be 0 already. And we also cannot have x as a negative number. So the conclusion is that x must be a positive number. So now if x is a positive number, then out of these 3 numbers given, which must be the largest? If x is a positive number, I'm sure, okay, I believe 3x will be bigger than x plus 3. May not be, but high chance that 3x will be bigger than x plus 3. And definitely 3x plus 2 will be bigger than 3x. So with this, I'm going to try out my PQ squared plus QR squared equals to PR squared. I am actually concluding that this should be the longest side. So when I square the two shorter side, add them up, I should get my 3x plus 2 squared. So from there, with this as the longest side, PR is the longest side. That means the angle opposite the longest side should be my 90 degrees, if it is even a right angle triangle. But in this case, it is. They told us it is. So PQ will be my right angle. So you need to sketch the diagram out if you cannot visualize it. Okay, now in page 8, some common phrases. Shortest distance from a line, from a point to a line, is the perpendicular distance from the point to the line. For example, if we didn't have this, if I tell you to draw the shortest distance, find the shortest distance from B to AC, or draw the shortest line from B to AC, you have to realize that there are many possible lines that I can actually draw, but only one will be the shortest from B to AC. The shortest line will be the line that forms a 90 degree with the base. So what you can do is to use your ruler, which has a 90 degree, or even better, if you have a set square, this triangle over here, just place it, and it will show you the shortest distance. So we carry on with practice 7. Part A, primary school kid also can do half times base times height, 180 if I'm not wrong. Yeah. So find the shortest distance from X to YZ. So for those of you who are at home, you cannot see the set square on my screen. We place it this way. We are making use of this 90 degree. Place it on the base of YZ and make sure the perpendicular line touches X. So you can slide from both ways up. Slide until it touches. So this line will be my perpendicular distance, which is the shortest distance. Looking like this. So indicate 90 degrees. Okay, so now we are trying to find this distance, the shortest distance, the red color line, using our answer from part A, which was the area being 180. So half times the base. Now our new base is 41. 41 times our unknown height. So let us call it H. So before that, you say that let H be blah, blah, blah. So H, and this will be 180. And then carry on with your algebra. Find that H equals to 8.78 meters. So this is an example without Pythagoras Theorem. It is just a refresher. Can we remember what we have learned? The concept in Sec 1. So in practice 8, we now include a little bit of Pythagoras Theorem. So finding the area again, not an issue. Part A is Sec 1 work. Half times base times height. In fact, it's primary school work. Find the length of AC. Now AC length, we have to find it using Pythagoras Theorem. So AC squared, we know that it is a right angle triangle, so it must be equal to 8 squared plus 18 squared. So let's find out the value first. 64 plus 18 squared, 398. I like to write down the value of AC squared first, or for that matter, any side square. I don't like to immediately just write down the square root value. You can do that. But writing down the square root value immediately from a calculator means that you are losing some accuracy already. You're already rounding off. Then later when you need to use the previous answer again, you do have the exact answer, the exact number. So from here, AC will be square root 398, giving us, yes, 388. I pressed wrong. Oh yeah, sorry, 388. Thank you. 388. So square root of that, 19.6977. Round off 19.7 cm. Okay, so this is our 19.7 cm. Of course, part C, hence or otherwise calculate the length of BD. Try and find this using answer in part A, using the new alternative base of AC. So half times AC, which is 19 points. Would you want to use 19.7 or 19.6977? Which one will you choose? 19.6977 or 19.7? Or will you choose something else instead? Yeah, square root 388, right? Might as well use square root 388. Super exact. No rounding off involved. Half times the base times the distance BD. This must be equal to 72. That is the area. So carry on, and you'll find that BD equals to 7.31 cm. So what are the concepts over here? First, the idea of finding the distance from the known area. So that was your Sec 1 work, that concept. The other is actually a Pythagoras theorem for finding the distance AC. That's all. Due Wednesday? Thursday, Thursday. And the rest are just variations of your Pythagoras theorem already. Okay, so I will just go through the remaining questions on Wednesday as well. Okay, Wednesday we go through the rest of the notes, go through some of the homework questions, and this one due Friday. Thursday, Friday. Okay? Any questions?